So our first section in chapter 2, writing and graphing inequalities. That is our objective, to write them and sketch their graphs. So for our warm-ups, we are asked to complete the statements with one of these symbols. Do we remember what these symbols mean? Very good. Greater than, less than, or equal to. So for number 1, 2 is less than 9. Less than 9. Negative 6 is less than 5. Very good. Negative 7 is greater than negative 13. Very good. On number 4, what do those bars mean? Absolute value. What is the absolute value of negative 8? And what is the absolute value of 8? So these are equal to each other. Okay, then on number 5 down at the bottom, the absolute value of negative 18 is 18. So negative 10 is less than that absolute value. In our notes, we need that an inequality is a mathematical sentence that compares expressions. We saw some examples of that in our warm-ups with things like the absolute value. Well, if it was negative 10 is less than the absolute value of negative 18. That was an inequality. They could involve variables. So we could have x plus 5 is greater than 16. That's an inequality. The variable expression, if there is one, could be on the other side. So we could have that 14 is less than x minus 7. These are all just examples of inequalities. All right, these are awfully small, so I'll make the symbols a little bit bigger, and we are going to talk about what they mean. So you need to be able to match the symbol to its phrase. The first one we have talked about, what does this symbol mean? Less than. This is a less than symbol. Okay, our next one faces the other way. That would be greater than. Next up is similar to the first one, but it's got a bar underneath it. Good. Less than or equal to. Less than or equal to. And as you might be able to guess, the last one, greater than or equal to. Okay, so whether you have these up and down, kind of like I've got them split up here, or you write it next to them, we need to be able to know what these symbols mean in a phrase. If it does not have the bar under it, it's just less than or greater than. If it has the bar underneath it, it means or equal to. All right, we are going to write each sentence as an inequality. Yes, it's going to be helpful for you to have these sentences in your notes before we translate them. So I would copy down the sentences and then do your translation. A number W minus 3. So when they say a number W, That's what they want us to use as our variable. That's a pretty literal translation. Minus means we're doing what operation? Subtraction. So we're taking W minus 3 is less than or equal to negative 2. Okay, so for this we need to be able to know which symbol is less than or equal to. The arrow part of it points which way for less than? The arrow piece, the pointy part? Points to the left, good. And then do we need a bar or not a bar? Need a bar because they put what part in there? The or equal to, and then a negative 2. Now eventually we will also be solving these, but for now we're just translating from a sentence to an inequality. Okay, the hard part for some of these is the difference between less than and is less than. If it is less than, that means we're talking about the inequality symbol. If the word is missing, then we're talking about subtracting. Okay, so is less than means you have to use an inequality symbol. 3 is less than. So let's start that off. We need a 3. We talked about less than, the pointy part goes to the left. Do I need a bar under this one? No, because they did not put the or equal to. A number n plus 5. Well, again, that part's pretty literal. Plus means we're doing what operation? Addition. So they said to use n plus 5. All right, the last one, 0 is greater than or equal to. Let's stop there. 0, of course, we have our number. Greater than or equal to means that the pointy part goes which way? To the right. Do we need the bar under it? Yes, because they had the or equal to. Twice a number x plus 1. Very good. Twice means times 2. So twice x is 2x, and then again, plus 1. Any questions about our translations? But when we see the word fewer than, what other word do you think could replace fewer? Less than. So if you want to write it kind of above there, fewer than and less than would mean the same thing. Also, I'll let you think about it first, but the is at least, that's another way that we haven't quite talked about it yet. So think about what the words at least would mean. We'll go over our answers in a couple minutes. Good. Number 4 is pretty straightforward. B is less than 30. Any volunteers to say what they got for 5, Dominic?
Negative something over 10 is greater than or equal to 2n minus 4.
2. Okay, I agree with most of what you said. I am going to use K.
I meant K.
Okay, no, it's all right. Okay, so then comes the decision of what symbol goes in between these two parts. So is at least, I would agree that at least means that it could be the same as, or it would have to be bigger than it. So is at least means that it would be greater than or equal to. If I need you to give me at least $20, that means it's okay if you give me $20, or you can give me more than that, but it can't be less than 20. Does that make sense? Is at least should translate to greater than or equal to. If you want to write that off to the side, is at least means that it would be greater than or equal to. That might be a good little note to have to yourself.
Like an opposite to at least. What's the opposite to at least?
No more than. Okay, the opposite of is at least would be is no more than. It's a good question. Could come in handy. All right, a little more vocab for us, or some ideas here. A solution of an inequality is a value that makes the inequality true. An inequality can have more than one solution. So with equations, unless it was an absolute value, if it was just a regular old equation, we usually had one answer to it, unless it was a special situation. Inequalities will usually have more than one solution. Okay, the set of the solutions is called the solution set. I don't know that you need to put that in your notes, but you can if you would like. All right, on example 6, we are checking a solution. So we are deciding if -4 is a solution. So what we're going to do is plug -4 in for x, simplify it, and then decide if we get a true statement or a false statement. Okay, so on the first one, when we plug -4 into x, we're not moving anything around, we're just simplifying. So what part of this could I simplify? Liam? Good, -4 plus 8. What is -4 plus 8?
-4, 4,
Just 4, good, +4. Nothing else is changing. So then I just have to decide, did it give me a true statement or not? So what would this statement read?
4 is greater than.
What do you think, Dominic?
Oh, excuse me, we forgot to adding a minus sign to the 3, by the way.
Oh, you are correct. We did forget to do that. I don't know that that'll change our answer, but you are correct. It should have a negative sign on it.
Well, and also on the 4 too.
Nope, not on this 4. Why not on this 4?
Oh. Well.
How did we get this 4?
We undo 8 on each side.
Nope, we're not undoing anything. We're just combining like terms. So Liam told us, took -4 plus 8 to get 4. All we did was simplify it. We're not moving anything around.
Oh, pardon me.
Okay, so how would we read this statement that we have out loud? Good. 4 is less than -3. Is that true or false? False. So is -4 a solution? No. -4 is not a solution. Okay, we can shorten solution to SLLN, or you can write out the whole word. -4 is not a solution in that case. So let's move on to letter B. Again, we're going to plug in the -4 for x. Why did I put parentheses around it? To show that I have to multiply. So when we simplify this, what can we simplify? Good. -4 times -4 gives me 16. So what would the statement read out loud? Careful. 16 is greater than -24. Is that true or false? It's true. Okay, it's true because the 24 is negative, right? So a positive number is always going to be bigger than a negative number. So in this case, -4 is a solution. Okay, if you end up with a true statement, then that number that you plugged in is a solution. If you end up with a false statement, the number you plugged in is not a solution. Okay, so I want you to try the ones down at the bottom on your own. You're plugging in a -6 I'll rewrite letter A just a little bit bigger in case you're having a hard time seeing that one. Letter A on number 7 is x plus 4 is less than negative 1. So on 7A, what are we plugging in for x? Good, negative 6. So we have negative 6 plus 4 less than negative 1. If we take negative 6 plus 4, what do we get? Negative 2. I'll write it off to the side over here. Negative 2 less than negative 1. Is negative 2 less than negative 1? Yes, that's a true statement. Negative 2 is less than negative 1. So because we got a true statement, negative 6 is a solution. So I don't have a lot of space down here, but we could say yes, or you could say negative 6 is a solution. Okay, you ended up with a true statement. It is a solution. All right, on letter B, what do we think? Is a solution, is not a solution? We didn't get that far. Some people are saying is not. Any thumbs up for it is? Thumb sideways for we're not sure. Okay, again, what are we plugging in for x? Negative 6. To start simplifying this, what's the first thing I need to do? Multiply. 4 times negative 6 is negative 24. The rest of it is staying the same. Remember on these, right now we're just simplifying. We're not trying to move anything around from one side of the problem to the other. So now what else can simplify? Good. The negative 24 minus 25. What does that give me? Negative 49. Okay. Is negative 49 greater than or equal to negative 2? No. So we would say negative 6 is not a solution. So for this one, negative 6 is not a solution. All right, this slide tells us how to graph an inequality on a number line. Okay, so an open circle is used when a number is not a solution. That will also happen if you're using the symbols less than or greater than, if you'd rather just write that. We use an open circle for these two symbols. We used a closed circle when a number is considered a solution, so that means that's when it has the equal to bar. So if instead of writing these whole sentences out, you just want to put open circle uses these symbols, closed circle uses those symbols, that's fine. Similarly on the third line, if instead of writing out the words greater than or equal to, you could use those symbols. If one of the greater than type symbols is used, we are shading to the right. Shade to the right. If one of the less than symbols is used, then we shade to the left. Okay, and it is important to know that last part. I would definitely write that down. Before graphing, the variable must be on the left. We can shorten a lot of this slide down with symbols, but you need that last line for sure. The variable needs to be on the left. So on these examples, we are going to be graphing each inequality. All right, so we've got some number lines set up so that we can graph these. So we have to decide first whether or not our variable is on the left side. So for example, 8 is the variable on the left. Yes, that's the left side. Variable is there. So that's good. We can start graphing. We are going to have to put a point at the number on the other side. But we have to decide if that point should be an open circle or a closed circle. Does anybody think they know? Lydia? Closed, why? Good. If we've got the ones with the equal to bar underneath it, it'll be closed every time. So I'm going to put a closed circle at -3, but that means I need to start labeling my number line. I would have 0 on there somewhere. So on this one, I am going to go ahead and count by ones. 0's not in the middle, and that's fine. I just knew I needed to have a -3 pop up there. I would like to see 0 labeled somewhere on your number lines. You should not just have a line, the one and only point that you need, and then start graphing it. Okay? So we've got all those dash marks labeled. We're going to put a closed circle at -3. And then I have to decide, am I going to shade to the left or to the right? Lydia, what do you think? To the left, why? Okay, partially it's pointing that way. That's kind of a little trick. If it's a less than, we shade to the left. Less than left. Okay, so your shading, I'm not super picky about as long as I can tell that it's shaded. Okay. Whether that's kind of squiggly shaded or side to side shaded, I'm not picky about it as long as I can see it. Okay, so some things that I will not want to see would be the number line with just a -3 shown on there somewhere. That's not going to work for me. If it's a number line and you've got all your points on there, 0, -1, -2, -3, and you go to graph your point and you just put like the teeniest little dot there that I can't really even see it, that's not going to work. It should be big enough that I can see your circle. And if it's open, I better be able to see through it, see some openness. It should not be so big that it takes up a good chunk of your number line. I don't want it obnoxiously large. Okay, make it appropriately sized. Same thing goes with the shading. I understand this sounds a little picky. Do we understand what the expectation is? Dominic?
To have like the appropriate size of a circle.
Mm-hmm. Yep, that's part of it. We got to have an appropriately sized circle, an appropriately labeled number line. Sometimes you'll be given number lines that are already labeled for you. Just use whatever label is already on there. All right, so let's start talking about number 9. Okay, why don't we go ahead and label some points? I know I need a 0 on there somewhere, and I need what other number? A 2. I need a 2 on there. So we could put our 0 here and count 1, 2, 3. -1 would go in the back. Okay, I know I need 0. I know I need a 2. Before we start graphing, my variable should be on the left. Is it? No. The variable right now is on the right side. That's not where I want it. So I have to pick up this whole thing and flip it over. If we do that, the x will be on the left. The 2 will be on the right. Dante? Yes, the symbol also has to flip over. Lydia? What? Yes, so now it would read greater than. So if we're flipping it, the symbol has to flip with it. Okay, and you can kind of look at these and see it's like a mirror image of it. We flipped the whole thing. Other people like to think about what the arrow's pointing at. It was pointing at the 2 when we started. It's still pointing at the 2. Now that we've got the variable on the left, we can start graphing. So do I need an open or closed circle? Good. Open circle because there is not an equal to bar. And then I have to decide if I'm shading to the left or the right. Shading to the right because it is greater than. We decide it after it's flipped. So once it's flipped, we kind of ignore the original problem and shade based on when the variable is on the left. So if you ever have to flip one and you want to cross out the original problem, that's fine with me. Just make sure you flipped it the correct way. Questions before we move on to number 10? Okay. Number 10, I know I need what number on my number line? 0. So you can kind of pick where it goes, and you can pick what you want your scale to be. I'll still count by ones for now. Okay, is the variable on the left? Yes, it is. Am I putting an open or closed circle? Open circle at 0, and I am going to shade to the right because it is greater than. We getting the hang of this? Okay. On number 11, I personally do not like to count by fractions on my number line. So I'm still going to just count by ones. But if I do that, I have to know where 1/2 is going to be. Between what two marks is 1/2 going to be? Liam? Good. Between 0 and 1. 1/2 is in between 0 and 1. So if you have to put something at a fraction, if you want to count by fractions, technically that's okay. I just think that's more work than it needs to be. So I would just put it halfway between 0 and 1. Is it going to be open or closed? Closed because the equal to bar. And I'm going to shade to the left because it's a less than symbol. All right, this is going backwards from what we just did. So now we have a graph. We have to come up with the inequality from it. Okay, now I know these markings might be a little hard to see. So they started counting with ones. They did not put a 0 on their number line. Not my favorite thing, but we'll go with it. So they counted up from 1 to 10. They've got a dark circle at 4, and they've got it shaded to the right. Okay, the other one, again, they counted up to 10. But this time, what kind of circle does it look like they have? Open at what number? 9. Good. And it's shaded to the left. Okay. Lydia? Okay. For number 12?
Yeah.
What did you get?
Greater than or equal to 4. X is greater than.
Very good. X is greater than or equal to 4. If they didn't tell you what variable to use, you can use any variable you want. X is a great variable. We had to have the equal to bar under it because our circle was closed, and it is shaded to the right, which told us that it was greater than. Of course, we used a 4 because that's where that point was. James, you got our other one?
No. Is it X less than 9?
Very good. X is less than 9 would be the inequality that gave us that other graph. Okay, again, variables on the left. We do not have an equal to bar because it is not shaded. It was shaded to the left, so it is less than. If you counted by ones, that's fine. What kind of circle are we needing? Open, because there is not an equal to, and we are going to shade to the left. Dante? If there's ever an equal to bar, it should not be open. So that one we didn't have a bar underneath it. Like it's just the symbol without a bar. Okay? All right, on number 2, open or close circle. Open circle. And it's shaded to the right. Okay, number 3, open or closed. Closed because there is the equal to bar and we're shaded to the right. And on our last one, open or closed, shaded to the left. Okay, questions, concerns? So look at if your circle is going to be open or closed, be looking for which way to shade. Those are the 2 big things. The point always goes at whatever number they're telling us to use. I remember that being a question last year. We decide on that point by whatever number it is that they are using. Okay? I am going to go ahead and flip because this slide tells us our homework. So we should get this copy down either at the top of our notes somewhere on our notes or in our planner or both. Notice that on a couple of these sections, 5 through 23, we're doing the odds. 27 through 35, we're doing the odds.